Hello. Today I wanted to give you a preview of Unit 3 in the Applied Calculus course. And in this unit, you start looking at the graphs of both the original function and the derivative, its rate of change. And I think that's something a lot of students get confused, is how the derivative, how the original interact with each other, and even the second derivative when you start looking at concavity. So I think it's a good idea to, when you start going over this, when you do wrap your mind around it, start building your note card that you're using for your final exam. Start building that today so that you will have it all kind of organized and sorted out in your mind, how the derivative, how the original function, and then even the second derivative, what all to look for when you're dealing with each one of those different types of graphs. The very first problems that you're going to encounter are the ones dealing with increasing and decreasing intervals. And when you're looking at a graph, I would definitely encourage making the graph as large as you can so you can see exactly where it's increasing and decreasing. And whenever it's increasing, think of yourself as walking along the graph. So you're walking uphill along the graph. So you're going to be walking, and this graph goes on and on forever and ever in both directions. So we walk uphill here from infinity, negative infinity to 6, and then again from 8 to positive infinity. So that's basically our uphill portion, our increasing. And then decreasing will end up being from 6 to 8, the x values. You only tell the x values when you're talking about increasing and decreasing intervals. So that's what you'll want to put in for your increasing and decreasing intervals right there. And you'll type it with using your, to the best you can, using interval notation. So negative infinity to 6 will be where you're increasing, and then decreasing, just put a comma when you want to separate your answers. So it'll be 8 to infinity will be the other increasing spot. And then we'll get our decreasing interval after that. So 6 to 8 will be your decreasing. And wherever you have a place, we didn't talk about this, but the place where they actually change from increasing to decreasing or decreasing to increasing is called a critical point or a relative extrema. While we're talking about relative extrema, I want to look at a problem where you have to find the relative extrema. And the relative extrema is the y value. So you want to see how far it dips down. And we can see here on this graph there's a relative min over there on the left side and a relative max over there on the right side, because it changes from decreasing to increasing on the left, and then on the right it changes from increasing to decreasing. So those are your relative extrema when you have those changes. Think about what the derivative is doing at each one of those places right there. Okay, you're going to have the derivative if you set the tangent line on the graph. The tangent line will have a slope of 0. And I think that's important to remember, especially when you go into like the next set of example problems. Remember that when the derivative is 0, that is where the increasing decreasing nature changes. The next set of problems changes the game a little bit by giving you a graph of the derivative and not the original function. So definitely make sure you're careful when you're dealing with this kind of problem. Whenever you want to tell where the original function is decreasing, so for decreasing, the derivative has to be negative for a decreasing function. And you'll investigate that as you go into more and more detail, but just remember whenever the derivative is negative, so below the x-axis, that's where you have a decreasing function. This one right here is actually below the x-axis from negative infinity to negative 1. And then it touches at 0, so that's kind of like a relative extrema when the derivative is 0. That's where it would change its direct, increasing, decreasing nature. Of course, does it change? Now this one doesn't change, so when it goes over to the next side from negative 1 to 2, it still stays below the x-axis, the derivative does, which means the derivative is negative. So it's still decreasing all the way from negative 1 to 2 as well. So it actually doesn't change. Even though the derivative is equal to 0 at that one place, it doesn't change its nature of increasing, decreasing. So there are some places where the derivative is 0 where it doesn't change from increasing to decreasing. This problem right here doesn't ask about where the function is increasing at all, but if you're looking for increasing, it would be this point from 2 to positive infinity, because the graph is above the x-axis from 2 to positive infinity. So just to kind of finish the problem, this is me selecting the answer. This one just wanted decreasing, so not increasing. We're decreasing whenever the derivative is under the x-axis. So we see it under the x-axis from negative infinity to 1, negative 1, and it's still under the x-axis from negative 1 to 2, and that's what you want to pick, option A. This next example right here is the perfect one to kind of show you how confusing it can be when you're going from the graph of the original function to looking at the graph of the derivative. This one right here is a picture of the graph of the derivative, and it wants all the relative extrema for the original function, which you don't have a picture of it. This is how you use basically the derivative to determine your relative extrema. This first one, on the left side, it goes from above the x-axis to below. So at negative 8, we know we're going to have going from increasing to a decreasing. That is a relative max. And then right there at negative 5, we have it going from below the x-axis to above. Well, that point right there is going to be a relative minimum. Okay? So that's how you determine your critical values or your relative extrema when you're using the graph of the derivative. Kind of look at where it's above and below the x-axis to determine those values. Once you do get a feel for understanding the connection between the original function and the derivative, I would definitely start making out your note card, like I was saying, to try to encapsulate your understanding, because I think this is easily one of the most confusing things about this unit is the whole connection between the derivative and the original function. You know, how do you use the derivative to find relative extrema? You have to look for those places where the graph basically crosses the x-axis, you know, where the derivative is equal to 0. Those are going to be the places where you have relative extrema occur. And I went ahead and finished out this problem right here if you do want to see the answer. The last few problems in the first section of homework deal with equations. So they give you a equation for the original function. And basically what you have to do from here is to find your critical numbers, find the derivative of it, set the derivative to 0, and that'll give you the possible places where it will change from increasing to decreasing or decreasing to increasing. I would definitely watch the video or do the Help Me Solve This to see how they set up the test or the interval test to see where it's decreasing and increasing. Basically all you're doing is picking a value in the interval. Let's say like you got a critical number that it was 2. You would basically pick a number to the left of 2 and to the right of 2 to see where, you know, if it's going to be a positive number when you plug it into the derivative or if it's going to be a negative number when you plug it into the derivative. So definitely watch a video or watch somebody see how they do it in example problems to test out whether it's increasing, decreasing once you get your critical numbers. But yeah, I think these problems are a little bit less confusing than the graph ones. Although you do have to do a little bit of work on these types of problems to find out where the intervals are for increasing and decreasing. In the very next section, 13.3, you deal with something called the concavity test. And they'll give you basically some graphs to experiment with, like what is concavity. Well, when you have your graph kind of like bowl-shaped downward, that's concave down. So you can see in this picture that part is concave down. And then once you go past the 0.1 comma negative 11 over 3, you get to a part that's like a bowl shape upward. So that would be concave up. And then the place where the concavity changes, that's what we call an inflection point. Okay, so they'll give you some examples where you have to find these intervals for concavity first to show you what concavity is. And then you'll get into something called the concavity test in the later parts, in the later homework problems, where you have to take the second derivative and set it equal to 0.